If you're building a multi-tenant app, you face a huge decision right at the start. Where do you put your authorization logic? You know, the code that decides who can see what. If you get this wrong, your entire app could be built on a foundation of sand. So today, we're going to talk about how to build a rock-solid foundation by putting security right where it belongs, inside the database itself. We're going to kick things off by comparing app-level versus database-level security. Then we'll demystify row-level security. After that, we'll get into the core patterns, how to avoid major performance problems, and some common mistakes to watch out for. And we'll wrap it all up with a checklist you can use for production. Let's dive in. All right, first step, the classic dilemma. Most of us, when we start out, we put our authorization checks right in the application code, in our API endpoints or service layers. It feels pretty intuitive, but it's a pattern that is surprisingly fragile. And this right here shows you why. With application-level security, a developer just has to forget one single filter, that one .eq clause in a sea of code, and boom, you've just created a massive security hole. It's a ticking time bomb. But with RLS, the database-level approach, that filter is automatic. It's inescapable. You write the rule once, and the database enforces it everywhere, on every single query. That is the whole game. So how does this magic actually work? The best way to think about row-level security, or RLS, is like having a bouncer standing guard at every single table in your database. And here's the most important part. By default, that bouncer's guest list is empty. They let nobody in. Your tables are completely locked down from the get-go. So what this really means is that an RLS policy is just a rule, a bit of SQL, that you write once. From that moment on, Postgres grabs that rule and automatically sticks it onto every single query that tries to touch that table. There's just no way for a developer to forget the filter because it's not their job anymore. The database itself is the enforcer. And our bouncer has two main tools to work with. First is the using clause. This basically answers the question, which rows is this user allowed to even see? It applies anytime you're reading or deleting data. The second tool is with check. This one is for validation. It asks, is the user allowed to create or change a row to look like this? This kicks in when you're inserting or updating data. And notice how update uses both. You have to be able to see the row you want to change, and the change you're making has to be valid. Okay, enough theory, let's make this real. We're going to walk through the two most common patterns that honestly are going to cover about 90% of what you'll ever need to do when you're building a multi-tenant app. The absolute simplest pattern is just direct ownership. A perfect example is a user profile. You should only be able to see your own profile, right? Well, this policy does exactly that. The using clause is just asking one simple question. Does the user ID on this row of data match the ID of the person making the request? If it's a match, they see the row. If not, as far as they're concerned, that row just doesn't exist. Now for the real workhorse, the multi-tenant workspace. This is the foundation of pretty much every SaaS app out there. Here, it's not about who owns the document, it's about who's a member of the team. So can you see this document? Only if a record exists in our workspace_members table that connects you to that document's workspace. Now, pay very close attention to that exists clause. It might look like a small detail, but it is single-handedly the most important performance decision you are going to make, and we're about to see why. So RLS is amazing for security, but a badly written policy can be an absolute disaster for your application's performance. In fact, it's probably one of the most common reasons we see databases grind to a halt. And I'm really not exaggerating here. The source material for this explainer calls it out directly. We are talking about queries suddenly becoming 10 times slower or even worse. This isn't some tiny optimization. This is the difference between an app that feels instant and one that's just completely unusable. And here's why. The slow policy on the left uses an in clause. This tells Postgres, hey, first go find all the workspaces this user belongs to, build a big list, and then check if this document's workspace is in that list. It's so inefficient, but the fast policy on the right uses exists. This is way smarter. For each document, it just asks, can you find at least one matching membership record? Just one. The second it finds one, it stops looking and says, yes. That short-circuiting makes all the difference. So what's the takeaway? 3 things. First, golden rule, always use exists for these membership checks. Second, for that exists to be fast, you have to give the database a cheat sheet. Create a composite index on your junction table on both the user ID and workspace ID columns. And finally, don't guess, prove it. Use the explain analyze command on your queries to make absolutely sure Postgres is using that index you just made. Okay, beyond raw performance, there are a few other traps that are even more dangerous because they fail silently.
Your app might seem to be working just fine, but underneath, your security model is completely broken.
This right here is the number one mistake without a doubt. You can write the most elegant, performant, and secure policies known to man, but if you forget to run this one simple command on your table, they do absolutely nothing. It's like buying a state-of-the-art vault door and then forgetting to ever close it. The whole system is off, and your data is wide open.
And here's another sneaky one. If you create an insert policy with a with check clause that's just true, you're basically telling the database, yeah, I don't care where they put the data as long as they're logged in. This means any user could create a request to insert a document into any workspace, even a competitor's, and the database would say, sure, no problem. Your tenant isolation is just gone. So let's wrap all of this up into a simple blueprint, a checklist you can follow to make sure you're doing RLS right in your production apps.
First, make it muscle memory. The moment you create a table with sensitive data, enable RLS on it. Remember that default deny mode is your best friend. For performance, it's exists, not in, and always add the indexes to make it fast. For safety, write separate explicit policies for select, insert, update, and delete. Don't use generic ones. And last but not least, test everything. Seriously, log in as different users with different permissions and try your best to break your own rules.
At the end of the day, row-level security really isn't an optional feature for production apps anymore. It's foundational. When you get it right, you're building a system that is fundamentally more secure and that scales effortlessly. So the question isn't whether you can afford the time to implement it, it's can you really afford not to?